Have you ever had a device that works perfectly for years but then suddenly stops working right? That's what happened with my Elegoo Mercury Plus Cure and Wash Station. When I tried to cure my Rhythm 3D prints, only half of the lights turned on. It was almost useless. In this video, I will show you a simple way to fix this problem with just one small trade-off. Let's fix it together.
And here is it. So, as you can see, this is the bar I was talking about. So this is lighting up and this one won't. Why is that? So I have to say the first thing we should do is get into it. Whoops. Okay, just wiggle left and right. And it should work. I see that this connector is exactly the same as this one, so we should mark them, and even this one is the same. Let's do it from left to right. So 1. This one is 2. And this one is 3. Just to be on the safe side, let's take a picture of it. It's always good habit to take pictures. Okay, so let's see. Now let's first put this to the side. Okay, let's see. That's an interesting button concept. Yeah, okay. So this side is more or less, yeah, uninteresting, I would say. So let's have a look here under our trusty microscope.
At this point in the editing, I realized I forgot to press the record button on the microscope, but let me assure you, I didn't find any suspicious areas during the visual inspection. Let's see what happens next.
Okay, so let's put it to the side and get the other half of our baby. And maybe the problem is on the LEDs itself, or the cable. This could be the LED strips. At least it looks like when I look inside, it goes in underneath it. Yeah, okay, I don't think that here is any logic behind this. So as you can see, we just have plus on both sides and minus. Let me show you. So I would assume this is plus for this side and this is the positive side for this row. So remember, this is working and this is not. And this, yeah, looks like ground. Over here is a fan, but yeah, that's not the problem. I think the best way to check this would be to get this back together and try to start it and measure. So let's see. Yeah, let's plug in the power of this thing. Let's plug it here. Okay, fine. Switch power supply, and you see, yeah, let me have a look what the buttons were. I can't remember. So okay, the first one is the mode button, so this is fine because it's lighting, and this one is time up, S3 is time down, and start is S4. Yeah, okay. So this means, yeah, and now it's, yeah, okay, interesting. I was always thinking how this one here detects if the lid is on Because when I put this lid over here, I can configure it. Now it works. But now I will lift it. Oops. Let's do the same. Click it here. And you see it's blinking and telling us, hey, I can't do that because the cover is not there. And what I have discovered, this sensor that looks like, yeah, it's infrared proximity sensor or something. So that means when I put my finger here, it's happy, you know? So let's put something over it so that it always thinks, yeah, the lid is on. So let's just use some Scotch tape. And let's put it over here. And hopefully this is enough. Let's lay it down. Yeah, that works. And yeah, that works. It's okay. So we need to short it, otherwise, yeah, we can't look directly into it. Well, it's not recommended. So there is a reason for that this cover is over there, because it protects you from the UV lights. So, okay, now 4 minutes and let's play. And you see for a slight moment. Oh, they are very, wow, they are hot. Really. Yeah, this works, but I can't let go. Because I won't risk shorting something. So I think I will shortly unplug it like so, and I will mount it. And let's have a look. Okay. And to protect my eyes, I found this. Yeah, it's for a laser engraver, but I hope it will also help me against this UV light. So always think on your protection. And okay, let's power it on. What I do need on top of this is our multimeter. And let's measure. Yes, let's see. So we'll enter. Okay, still. Okay, the Scotch tape isn't enough to block it. Yeah, that's. We are good to go. Now let's measure. Remember, this is just experimental. It's 27 volts. Oh my gosh. Okay. More than I expected. Also 27 volts. Okay. So the voltage is getting in. Oh. Oh. You see that? Of course you see that. You're not in dummies. Okay, so there is. I think. Okay. Let's do this again. 1 minute. And let's see. We'll push on here. Okay, wow. After looking through these green glasses, oh, that's all very reddish now. Interesting. If you're wondering why my setup looks a bit different as usual without the green mat and stuff, and yeah, you can't see the rest over here, but let me show you. It looks completely different because yeah, we are moving to the upper level, so that's why it's all experimental at the moment. So yeah, feel free if you like stuff like this, go for it. I have plenty of stuff like this and mods and fixes, so just have a look at my channel and I hope you will find something. Thanks. So let's now remove this here, yeah? You know what? No, let's not remove it. Let's see on the microscope. So I think it was this one over here. If we can solder it, or if there is a bad solder joint or something. Let's just use some flux. And let's see if we can solder it. And try if I can get my Fume-Extractor, the one that I referenced in my soldering tutorial, in the first part, so to say. If you're interested in learning soldering, I will cover all the tools and stuff in this video. I will link it in the description and on the right side of the screen. So let's turn it on and let's see if we can get something on the joints here. Problem is that we have underneath the big heatsink, which will get rid of most of our energy we try to put into it. No, it's not working. I think I really have to remove it first. What I could also use is trying to use a different tip. This is not the perfect tip for this operation. So we have to remove this. Put it with a tweezer because it's hot. So let's put this in here. Put it in fresh flux. I think that there's the coating on, so probably the best way is to stretch it a bit. I will do this with my grinding fan, but you could also do this with, for example, a tweezer. Yeah, that's better. You see, I scratched here a bit. I'm not sure if I connected something that I shouldn't have connected, but I don't think so. Let's see. Nope. Yeah, come on, let's remove this. Okay, this is paste. I'm now in diode mode, so it should light up dim at least. See, it's lighting up, so this one is fine. It's just the second one here in row, also lighting up. Also lighting up. Hard to see that it works. Also lighting up. Lights up. Lights up. Another one we mistreated. This one is not lighting up. And the last one does light up. Let's try something. I do have here, LED power supply. Movie's LED power supply. Let's just, it was 27 volts. Limit the current to 900 milliamps. You see, this lights up. I need to put on my greenish glass. So, okay. Wow, that's very bright. Incredible. Okay, so this works. This won't. Wait, any way to power this more easily? Let's see here. Let's see here. Otherwise I can't measure directly while holding the stuff here. Doesn't work. So let's see. Okay, nice. So this works. Okay, so let's measure some voltage here. Okay, now let's do the same on this side here. Let's see if we can measure something here. And yes, we do. And now let's see. Here we have something. Here we have something. Yes. It's getting less and less. .3. Let's see if we are able to get this one here out. Full power, 500 degrees C and 100 Fahrenheit. 120 F-low. So this is the LED, this one is garbage unfortunately, so we have just 7 LEDs out of 8. Of course I don't have any replacement that would fit this LED because I have no idea what kind of LED this is. Yeah, I mean it's an UV LED, I know, but I have no clue which exactly. So the only thing that we can do is jump this here somehow to make use of the left 7 LEDs. But let's first try if we can just bridge it and see if it will work. Okay, so you see here, that's my left power supply. Let's go to the, it was 27 volts, and let's do 600 milliamps at the maximum that this circuit can draw. Power it on. Let me get my green wonderful glass. And let's see what happens when we short it. And you see it's lighting up. But as you can see, it's also drawing completely the 600 milliamps. That's too much. When we do the same with the other row that is working, like so, you see it's drawing around 500. So I think this should be the sweet spot even for the other side. What could we do? It's definitely not a possibility just to use a jumper wire because it's getting boil hot and all the other LEDs would draw too much amperage. So we need some kind of a resistor. Yeah, so let me see what I got. I have here some sample books of SMD resistors. They are quite handy, and they are different sizes. For example, this one here, oh my goodness, that's this here, these little points, these are the resistors, and you see that's more tiny than the tip of this tweezer, so it's insane. So this not gonna work. Then we do have 0402. See, it's quite bigger. I would say it's the double the size, but still not big enough. I also have 1206. So these are the biggest SMD resistors I have at hand. You see they are much bigger, and you can probably soldering them with no issue with hand if you have good eyes and a stable hand, of course. So let's check it out. Let's use, let's go with 10 ohm and see how much it will draw. So we need some way of getting this. Let me turn off the LED power supply for a moment. So I need to put it temporarily here. Let's use some tape. I think that's the best way of doing this. Let's try to place it. What we want to bridge is the smaller ends, so left and right. And I think this should make contact. So press it down a bit. Let's see what is happening. Turn it on. Oh my god. Wow. That's getting quite hot. Oh, I will burn myself when I do it too long. Ow! Holy moly. So let me try to do it under the microscope. Let's see, I think it will burn. Yeah, I see clearly how it's melting the tape. Yeah, it's smoking. So this is too hot, but what you also see is that it's just 476 milliamps. So this is a good value if you ask me. So I limited still to 600, but it's just drawing 470 around this. You see here, there is a hole. So this is not working, and the reason why it's not working, the energy going over this resistor is just too high. I think they just can have or handle 0.25 watts or something, and we are way higher of this. What we can do is put more in series, for example 4 or even 6, and it will split. So we have, more resistors in parallel with the same outcome, 10 ohms. For example, if you want to use 6, so we would need a 60 ohm resistor 6 times, and this will result in a parallel version of 10 ohms. Or if you would go with 4, it would be 40 ohms. Each resistor 4 times would be in parallel exactly 10 ohms. So to have more buffer, I will go with 6 of them. Here I have 62 ohms. That's the closest I have to see. I have 56 or 62. That's all I've got in the sample book here. So let's go with the 62 and 6 of them. It should be close enough. Not sure if it will work. How can we position them? Let me think what the best way would be. Let's place flux. Always use flux. I can't stress that enough. I'm doing this in all of my videos where I do solder. Flux will help the solder flow and makes your life so much easier. Let's see if we can manage something. Just for reference, I know that this is not looking pretty, but this doesn't matter in this case. It just must be solid and working. So let's measure. So we are in ohms mode, so that's good. So let's see. And you see, we do have 10 ohms, so this is working. So now let's check. Okay, let's do the continuity. It's easier. Now we see we have continuity from this side to this side. And we have continuity from this to this. And that's still continuity for him, but you see it's 10 ohms. So this, theoretically, should work. Green glasses and power. And we see something that's good. And as you can see, we have 470 milliamps. Now, you see, I can touch it. Let me show you on the microscope. You can touch it without any issue. It's, of course, getting warm. But, yeah, no biggie. Nice. Then we need the cover.
With very little effort, I was able to restore the functionality of this station significantly, and the best part, it cost less than $1 freaking dollar. We have gained 7 working LEDs while sacrificing only 1. You are interested in soldering, but you don't know where to start? Watch the video on the right and I will guide you through it. And as always, happy tinkering!